Howdy everybody, and welcome back to the Chip and Dale tutorial. So last time I told you that we would be adding the move carry state. So one of the key features of Chip and Dale is that your characters can pick up different environmental objects and throw them around to take out enemies. And not on a date. Okay, so when your player does this, there's a special state that they go into to do this. You know, I probably don't even need a special state, kind of, but I did a special state for it. This is all kind of hindsight programming on my part. So, anyways, let's get cracking. Okay, so to do the move carry state, first off, we need to figure out what is the event number for that. That is 2. So let's add our move, our carry move state. And second thing, the code for the move state and the carry move state is essentially identical. So we'll skip the states over there for a second, and we'll just walk through the collision and movement code real quick. I just want to make sure everything is exactly the same. Alright, looking like it is. Speed fractions, good, we got that. Speed, yeah. Now, how about animations? Image and speed, if x underscore speed underscore is equal to 0, then image underscore speed equals 0. Manual sprite change is true. Give us an idle sprite. And if it is not, change my scale to the x speed. Yeah, that's all identical. So, now that we've done all that, wow, that was a lot of programming really fast, right? So, let's add some additional animations to support our pickup object. So we have a variable called pickup that we made back over in the create event. And pickup is going to hold some information about an object that we pick up. Actually, before we go into it over here, let's go back to the standard move state. And we have our jump state and our duck state. We want to also add in, let's see, we have our jump state, we have our duck state, good. So we are going to add in our lift state, and this is actually the last of the changing events. So that'll actually be very good for us because we don't have to add any more of these things in here. So let's add this in. Pound region lift state. Pound end region. And okay, so this is going to have a bunch of code in here. Let's see what we can do about this. There we go. So to start off, we're going to declare a couple of variables, bbox check and pickup. So if image x scale is greater than 0, e.g. Check on our right side, else check on our left side. And what it does is it checks to our right, so it gets a pixel position immediately to our right or immediately to our left. So you can change this number to like 5 or 10, depending on how far away you want to be able to let your player pick up a pickupable, a throwable object, a carryable object. It's kind of hard because there's pickups, which are the pickup items that give you points and scores and stuff, but there's also the pickups, which are the throwables. So maybe I should be calling them throwables instead of pickups, but anyways. So pick up the top first. So we are going to be checking 2 positions because our character... So if we were to look at the game, we have a 3x3 here and a 3x3 here. And so let's see. Yeah, well, that's about as close as I can get it. So Our characters are about 1, 2, 3, 4, 5-ish. Well, no, they are 5 wide, and all of our throwables are 3 by 3. So therefore, we can fit a check for a 3 by 3 object in here and a 3 by 3 object in here. So we check at the top first because we want to pick up the top object first. So that way we don't end up with a object hanging in midair, though that still does happen, but that's just because that's the way it was in the original game and I didn't bother coding it better. So we create a fake collision object with no collision box at the location of the pickup and destroy the pickup. And this was something I came up with because I wanted to make sure that our player wasn't getting stuck inside of the hitbox of a collision of a pickupable item. Though later on I did find another way to do it rather than making a pickup object, but this kind of worked fairly well too anyways, because then you don't have to remember what object it was that you picked up so much as you just have to remember that you have a pickup object that you're carrying around. To support this, we're going to make a couple objects here real quick. Go down to, let me zoom out a little bit here. Go over to our parents, and we are going to create a new parent here. This will be parent underscore carryable. And this, does it have any code in it? Yes, it does. We have a couple variables. Create event. And there we go. We just have a heavy underscore equals false, held underscore equals false, and used underscore equals false. And these will be used with different carryable objects. Secondly, we are going to make a object pickup. So let me pull up code for that as well, if I can find it. Ah, yes. It's over here. We put it into room objects. Objects underscore pickup. And again, we have a create event. And in this create event, we set our image speed equal to 0 so we don't animate. Image index equals 0. Sprite underscore equals no one, so we don't have a sprite yet. We will have a sprite in a little bit. And heavy underscore equals false. And this is kind of the same heavy as that heavy, which we'll be setting later on, depending on what we got. So, and then we add a draw event. And for this, we are just going to use the drawSpriteExt function. And for our sprite, use our sprite variable. Then we have everything is pretty much defaults after that. So that's that for that. And it doesn't have a parent or anything, so we'll just ignore that. Turn it off. We don't need it anymore. Parent carryable. Do we need to do anything with that? No. It's all done, so we'll kill it off. And just for effect, so we can test this, we're also going to make an object box. Object underscore box. Come over here to our sprites. Objects, sprite box. In the create event, actually, I don't even need that. We can just go back to the parent carryable here. Image underscore speed is equal to 0 and image underscore index is equal to 0. That should be good in there. Come back to our box and set its parent. to be parent carryable. All right, so that should be good. All right, so we should have yep, those all go back to red. So we have our underscore pickup var that we declared here. Collision underscore point, bbox check, bbox top. So check at our top on the right or the left for a carryable object. And we don't need precise collisions or not me. If underscore pickup does not equal no one, so if it finds that there is something carryable there, then pickup underscore is equal to instance underscore create underscore layer, and let me move back to my code over here on the other one. Yes, I did forget something here. I knew I did. Before we do any of this, we need to check if pickup underscore input underscore. So if the player puts in the pickup input, then do this check while you're in the move state. If it finds a pickupable there, then pickup underscore is equal to instance create underscore layer, and it creates a throwable object pickup. That's what it makes. So we have a layer called Throwables here, and this is for animation, so that enemies appear above throwables, but throwables appear above pickups. That way you can hide pickups behind throwable objects. So we have object pickup. We create a object pickup. Pickup underscore dot sprite is equal to underscore pickup dot sprite index. So back over here, we got the object ID of, was it the object ID or the instance ID? Instance ID of whatever we are picking up. And now we're going to use it to populate some variables. So sprite is equal to sprite underscore index. So that way our object pickup looks like our pickup object. The pickup underscore name underscore is equal to object underscore get underscore name. And we'll be doing pickup to object underscore index. We'll be using this for a switch later on for determining what to do when we throw the object. And pickup underscore dot heavy is equal to underscore pickup dot heavy. So if our pickup object is heavy, then make our object pickup heavy. And this is so that we can do an animation. Then instance destroy underscore pickup. So we don't want to leave behind a crate. Let's put a couple crates in here. We don't want to leave behind a crate when we pick up the object. And so this was a bbox check on the top. Then if there is nothing there, then so if underscore pickup is equal to no one at the top, then check at our bottom to see if there is a pickup there, and if there is, do the exact same thing again. So, and if we got something, go into the lift animation state. If pickup underscore does not equal no one, so if we actually did pick up something, then if pickup underscore name underscore is equal to object box, then pickup underscore dot image index is equal to 1. So boxes, let me pull up the sprite here real quick. Objects, box, have two image indexes, and the second image index is the sprite for when they are being held. It's slightly different from the ground image for some reason. No idea why. That's just the way it is in the game. It's the only one that does that. Image index underscore equals 0. Image speed is equal to 0. This is for your character. And actually, I'm paranoid all of a sudden that because I just remembered that the Windows, the little Windows thing hasn't popped up yet, and usually it does by now. Anyway, so object input dot alarm 3 is equal to -1. This is resetting the input delay, and pickup underscore input underscore is equal to 0. That way we don't immediately try to throw our object when we've just picked it up. Make our state equal to the lift state. Set our iframes equal to true because you don't take damage while you're picking up something. And let's go over to the lift state from here. Alright, so real quick, we're going to go over to the lift state. And this was kind of a bugger trying to figure out how to do these animations for this. So, enjoy them. This is like 50% of my programming time was spent on these animations here. Lift state. And here we go. Region states. So real quick, we're going to go over to animation. Manual underscore sprite change is equal to true. If animation underscore timer underscore is less than 3, sprite underscore index is equal to asset underscore get underscore sprite. And it should be the duck sprite. And we can now start using that pickup underscore variable that we set back over here. Pickup underscore to manipulate the X and Y position of our pickup object. So pickup underscore dot Y is equal to bbox top. So the character's top position when we're in the duck, when we are using the duck sprite, the top of the pickup mask, minus sprite underscore get underscore height, pickup underscore dot sprite underscore times 0.5. So half of the sprite height. Otherwise, then we should be in the carry idle state, and the box should be positioned directly above us at this point, I believe. Pickup underscore dot Y is equal to bbox top minus, well, no, it's not directly above us. This would be above us, but to the right still. And of course, increase our animation timer. And when our animation timer is greater than 8, we will leave the lift state because we have completed it. Animation underscore timer underscore is equal to 0. Pickup.y is now directly above us, plus 1. And there's our X position as well. Pickup underscore dot held underscore is equal to true. So it is now being held by us, and we'll turn it to false when we throw it. State underscore is equal to player underscore states dot carry move. Iframes underscore is equal to false because we are no longer invincible. And play the item lifted sound. And go back to our carry move state and exit. Okay, so I hope that logic worked out for you. Don't move it while in this state, not even gravity, by the way. It's just the way it was in the game. You would, if you manage to pick up an object while you're in midair, you will be floating in midair while you were in the pickup animation state. Luckily, it's so quick, you almost don't even notice it. So I guess that's why they decided to leave it that way. So let's go back to our carry move state. I told you that we were going to do some animations with this. So carry move state was 2. There we go. Let's pull out the animations. So we move the pickup with me. So after we have done our player movement, then we want to move the pickup object so that, again, it is back on top of us. So it's at our X position, it's at our Y position plus 1, and the image X scale is equal to our image X scale. So if we have turned right, it will be facing right. If we've turned left, it'll be facing left. And we also have this create sweat particle. So if the heavy variable is equal to true, then if there is no object underscore sweat underscore particle, then we want to create this object sweat underscore particle on the particles layer, which is right here. It's right here, and that's above our player specifically, which is on the instances layer, so that way it appears in front of the player. Let's see, we also have underscore particle dot image X scale is equal to negative image X scale. And the reason why it's negative image X scale is because I drew the particle backwards. Because that's the way I would roll. Alright, so let's see, we just need to make that object here real quick. Object underscore sweat underscore particle. Give it a name, and well, actually, real quick, gonna want to make a subgroup here for effects and move this into there. Give it the effects particle sprite sprite sweat drop, and this is going to be fairly simple, but at the same time complex. We are just going to cause it to exist for a couple seconds and then destroy it. So sec times 0.15. That's how long we want alarm 0 to exist. In the step event, we are just going to have it y plus equal 1. That is so the particle falls from our brow, as it is described, I guess. Alarm 0. When alarm 0 is triggered, instance destroy. And last but not least, draw. And we want to draw this particle flashing. So every other frame it won't exist, because that's the way that it worked in the game. I don't know why they had it so that every other frame it would disappear, but apparently they did. It might have been some sort of issue with how many particles and whatnot they could show on the screen at one time that they did. That'd be why they did it. Let's go back to that carry move state. Let me pull back up my code here, because we copied the move state code for this for the most part, but we need to do some changes to these states over here. Jump state. So for the jump state, it's kind of similar. If jump underscore input and on underscore ground, we need to, however, add in a variable right here. So instead of just being y underscore speed underscore plus equal jump speed, we need to check if the object is heavy. If the object is heavy, we only jump 0.75 times as much. Otherwise, we can jump as normal. Then on ground, and instead of going into jump, we go into carry underscore jump. Object underscore input at dot alarm 1 is equal to -1. Use up the buffer, speed index, and event. If we are not on ground, then we go into carry underscore jump again. And while we are carrying an object, we cannot go into the duck state. However, we can go into a hide state, and that's going to be a big one. That was one of the other things that took me the most time to figure out how to do. But in between these, I'm also going to throw in a throw state. So these are the last ones here. And I believe that next episode, we will be covering the hide and throw states, because I don't feel we have enough time for doing both of them in this episode. So real quick, into this throw state. Oh, wait. Pickup underscore input underscore, then x underscore speed underscore is equal to 0, because we cannot move in the x direction while we are throwing. However, we can move in the y direction. So we will throw, but we will be following while we throw, but we won't be able to move in the x direction if we were moving in the x direction beforehand. Image index is equal to 0, speed equal to 0. Change our player state to throw, and that will have its own nice little area. And end region. And use up our timer, our input buffer. You know, I should probably just make this a script that kills all of the input buffer alarms when you do it at one time, rather than just trying to individually change it for each one. Anyways, and then use the event user. And back to our hide state here real quick. We're going to change the code up here. So not only do we have to check if our input is going down, but we also need to make sure that our pickup is an object box or the object steal box. If it is, then our x speed is equal to 0, y speed, image index equals 0, image underscore speed is equal to 0, and our state underscore is equal to player underscore states dot hiding. Iframes is equal to true because we cannot be hurt while we are hiding. And I tested this very carefully with frame by frame precision to make sure that immediately on pressing down you can no longer be hurt, instead of having to wait fully for the animation to finish before you can't be hurt. And it is definitely as soon as you press down that you no longer can be hurt. Then of course execute our new user event. Alright, I think that's everything for today, and next time we'll get into our throw and hide states. Thank you very much for coming along, everybody. Remember, if you have any questions, please leave a comment, and I will answer them as soon as I possibly can. In the meantime, good luck with your programming.